how did you find out about QRS and how did you get that interest in rocketry initially?
Um, well, actually, the interest has always been there because when I was still at school, this is still back in South Africa in a city called Kimberley. You know, the place where the diamonds come from, the big hole of Kimberley. You know, the biggest man-dug hole in the world. Yeah. When I was still at school there, I had, you know, like most kids, we had been messing around with making gunpowder and the likes of that, and sugar and potassium nitrate mixtures. At school, we had a subject called metalwork, which, you know, like we had woodwork and metalwork, and the metalwork thing is where you learn to weld, and they had big lathes. So I actually, when I was, I don't know, 14 years old or something like that, I lathed a little rocket motor. It was basically just an aluminium tube with two screw-in plugs, and the one had a hole in it. It exploded spectacularly, of course.
Filled with gunpowder.
It was compressed, but it was way too violent. Anyway, yeah, it made a spectacular bang in the backyard, and so me and my brother had always been messing around with that sort of stuff, making little fireworks and the likes of that. So yeah, so anyway, me and my brother, who's also here in Brisbane now, by the way, structural engineer, we had been messing around with these sorts of things, and I have a mate that lived just around the corner. He was, you know, he's now in Perth, yeah, so we've been messing around with that, and you know, the oxyacetylene things, you know, all the bad old things that you shouldn't be doing. So the interest was always there. Of course, didn't have a clue what we were doing, not even remotely. So, and then, you know, decades later, we're here in Brisbane, and I stumble across this thing on YouTube, high-powered amateur rocketry, and they're doing it in the US, and they're flying at Black Rock Desert. I thought, damn, that looks good.
Chose the wrong country.
Yeah. And and then somebody told me, did you know that there's a club in Brisbane? I said, no. Really? Is there a club in Brisbane? I said, yeah, it's something like the Queensland Rocketry something. And I looked it up, and sure as hell, there it is. and of course, I went there, and it only took about 15 minutes for me to realize, yeah, baby, this is it. So, yeah, I ended up buying a couple of black motors, you know, black powder motors and so on. And the very first thing that I built was a Saturn V. It ran on a C or a D size motor sort of thing. It was, you know, the cardboard thing. But of course, you know, the first time it comes down on the chute on the fins, the fin is off, and so I thought, no, I got to do something a little bit more robust and a little bit more, you know, get a little bit more bang out of it. So yeah, and the whole Tripoli thing started there.
Yeah, so what year was that you think you first turned up to QRS?
Might have been 2009 or 10.
Okay. Yeah.
Yeah, I think it may have been 2009 because I just started working. I'd finished up with an architectural firm and started working for a large contractor. A large builder here in Brisbane, and I remember sitting in my office over there, you know, having a look at the website and so on. So it must have been 2009.
Okay.
Anyway, yeah. So.
And where did you get the Saturn V kit from?
That's a good question. I think I may have gotten it from Australian Rocketry as just a kit. Okay. Yeah, I didn't buy it online or anything. Yeah, so yeah. Anyway, so that was the first one. Soon sort of moved on to getting to you know, reloadable motors, and the whole Tripoli thing got in play there. Didn't end up getting my my explosives license until much later. Should have gotten it earlier, but never ended up sitting with a lot of propellant or anything. So my level 1 was a complete disaster, of course. I built was a pit bull, I think.
Yes, and sorry, just cut you off there.
Yeah.
I think you gave it to me after a KO or something, and then I gave it to my son. He loves it.
Yeah,
but anyway,
excellent. Anyway, that was a public missiles kit
Yep.
that I think I also got from Australian Rocketry at the time. But not having a clue as to the proper glues and stuff to use, and those plastic kits are a bit of a pain in the behind, because some glues stick to it and some just don't.
And the quantum tube, right?
Yeah, that's it. That's exactly it. And it had that other thing, that the piston that came with it. It always got stuck, and it was just messy. But that's I'd flown that on my first attempt at level 1, and I think it was exactly that. The piston got stuck, and the thing just lawn darted. The second attempt of that one was, I at the time still drunk the Kool-Aid that JB Weld is the right thing to glue everything with, and that was just a bad mistake. It doesn't work on quantum tubing, well, not in my experience. Admittedly, if you sand it properly, it probably will work, but it's too hard and brittly.
I was going to ask you about that, because I've never had a problem, but I've only ever used it on the retainer, motor retainer.
So colloidal silica sort of based glues is what I ended up going to, especially boat building sort of glues, which tend to not be as brittle because they're made for taking punches, unlike sort of aerospace glues that are supposed to be stronger, but it's hard. You hit it with a hammer and it falls apart. So I blew some fins off of that pit bull as well, and it's in those early stages that I realized that the paint that you use is actually fairly important. And it reduces all the hassle that if you're using rattle cans, you can get a decent finish, but it takes a week to dry, and it's really painful. So automotive 2-pack paint is what I moved to quite early. Even then, I think that I remember I painted the thing red. I bought some 2-pack paint for it, and that goes on real quick. It dries overnight, and it's rock solid then after that, and you can heat cure it as well. You put it in the hot box and bake it.
So I've looked at that rocket quite closely, but what did you use for epoxy on that then?
Later in the piece, it's difficult to say. I mean, that's I'm not exactly sure what I did use on that level 1, but I basically moved on to EpiGlue. After that, and I'm still using EpiGlue now. There's a big sun hood on a window there at the front of the house. All of the threaded rod that goes into the concrete wall has been EpiGlued in place. So I still use it today, and you can still buy it, no hassles. I mean, a lot of my go-to laminating epoxies have disappeared. I mean, CG Composites was the place that I used to buy all of my araldite, what was my primary laminating epoxy for building airframes and so on. But CG Composites have closed down, and the Huntsman brand, which owns the araldite stuff, I don't think they even import into Australia anymore. So the araldite K3600, I remember, was the K3600 was the kit. The LY3600 was the product, the actual product. And I bought that in large quantities. In fact, they've got great long shelf life. I still have like a 25-litre drum of this stuff, which I on occasion use for whatever. Anyway, that was in the.
So your third L1 attempt was successful?
I think it was the second one, but But you know, it's blurred in the past. There's been so many builds since then. So, but all I do remember was that L1 was for me the hardest because I had to make a mental shift. Jumping from building a toy into building something that's not a toy. That was a mental shift that was necessary, and once I did that, everything became a little bit more clear. So the level 2 one, which I went through these things relatively quickly. The level 2 was a scratch built small, like a 4-inch Sledgehammer replica. Which it was, I think it was just motor ejection still, flown on, I think it was something like a K550 or something like that.
Okay, so when you say scratch build,
yeah,
can you tell me what that meant for that particular?
For that specific one, I bought some tubing, which was that blue, I forget
blue tube from John Wick.
Yeah. Okay, so bought some of that. In that case, had bought a nose cone, just a plastic nose cone, and cut the fins from G10 and so on. But it was, it was fully self-designed and fully self-assembled, except I bought components for it. So I call it scratch built. The key was that at that time, having used Roxham, the whole thing about balance and your center of pressure and all that sort of stuff became a little bit more clear. And so that worked first time, no hassle.
And had you done any scratch build rockets between your L1 and L2? Or was this the first?
It would not have been the first. No, there were a couple of small ones which sometimes worked spectacularly well, and sometimes did not work spectacularly well. I remember specifically there was one case where, and it's one of the reasons why I went away from Roxham in the end, was I did a fairly long, skinny, like a 38 millimeter minimum diameter sort of thing. It took a 38 mil motor, and the fins, I had done 6 small fins. The fin area was sufficient. The simulation software, Roxham, indicated that it was stable, but when you flew it, it was not stable at all. And I think in the end, it was a limitation of the software where once it gets up to speed, then of course your center of pressure moves. And there's a shall we say an airflow shadow of the nose cone. Basically, the faster you go, the less the area of the fin that's at the base of the fin, the less effect it has, because there's no real airflow over it. It's basically in a vacuum. And if your fins are short, very short, then at some point they just not in any airflow anymore, and then no fins. And of course, this thing just did all kinds of fancy tricks up in the air.
Nice.
That was an important point. I later messed around with just 3 larger ones. They look cool, but in my later designs, I've always settled on 4. 4 fins being the optimal. And the primary reason in that sense was that with 4 fins, you get the same fin area as 3 larger ones. With 4, if you look at what was Open Rocket, which was my go-to design software, it always seemed to indicate that you get better stability out of a 4-fin arrangement than a 3-fin arrangement, even though the 3 fins were larger. And large fins are dangerous when you're doing high performance flights, right? You need to keep them as small as you can reasonably get away with.
Yes.
So that and look, let's face it. If you think about any military missile or rocket, they always have 4. They never have 3. So, and I think that's sort of part of, it boils down to the same thing. If you have 4. You apart from an XY directional thing, which allows you to then have better control over the rocket or the missile, it also means that the fins are a little bit smaller. So,
Okay, yeah, I mean, I guess 4 fins pushes the CP back further, which,
yeah, that's it.
okay, no, that's very good.
Yeah, so
So
yeah.
that's pre-L2.
Yeah.
So they had the L2 launch go. So I assume that was at Cedar Grove.
It was at Cedar
On
Grove.
a J motor.
Yeah, it was a J.
Okay.
It wasn't a K. You're right. It was a J something. But exactly what J motor, I have no idea anymore. But it was an Aerotech. That I do remember. It's before we even had access. Yeah, it's before we had access to CTI. Yeah, and it was, look, it wasn't particularly high. I think it was 1,200 feet, something like that. Single deployment.
Yeah.
No reason why you can't use a single deployment. And in fact, I actually like single deployments, to be honest. Even, I mean, you can't do it with the really high flights, but I still have one rocket left. It's that one that's up there. Great, yeah. That's my little travel rocket. Okay. Which we can have a look at in a minute, but that's just a single deployment, flies on an H, does 6,000 feet, single deployment.
So when you say single, you don't mean motor, you still mean electronics?
Yeah, it's fully electronic and tracked and everything, so, and it's got that same, you know, the hand grenade thing, you just pull the pin and everything wakes up and it's good to go. Yeah. Awesome. But that I had that over in New Zealand. I flew that in the US, and the reason it fits in a suitcase. You just stick it in the suitcase, and the motor casing you take with, and you just need to source a motor wherever you are.
We'll talk a bit more about that later on. In one of the trips I made to Blake's place. Yeah. Okay, so between L2 and L3, what was the when I mean, you would have known from the start you want to do L3, I guess. Yeah, absolutely. So you've done your L2, you've done that pretty easily. What's the thinking there? There was builds, more launches? Yeah, I got deeper into airframe design and manufacture. I think if just thinking back, probably the more important build that I had done between L2 and L3 had been the small Tintin rocket. Yes. That was quite a challenging, quite a challenging build, because I hadn't really done complex airframes yet at that point, and especially not with ones that had those outboard nacelles, which turned out, I mean, you have to be true to the original Tintin book, of course, but what a nightmare that thing was to make work. So why don't you tell me about how that rocket should perform? Like, it was a central motor, were you air starting, everything on the ground? Just tell me about that. That's exactly right. And what motors you were using? It had a 38mm mount in the middle, which was J. It was just with J's, not H's. And then the outboard, the 3 outboard nacelles had G64 motors, you know, what was that, 34mm mount, what was 38? Was it no, it's less. 29. 2029, that's the one, yeah. But I remember G64s, Aerotech G64, you know, the white ones in there, and they would air start. And I had actually, into the fins, I had laminated in a curved tube that you could put your wires through for air starting. It wasn't head-end connection, head-end ignition. It was, you know, just up the bottom, which I was worried about, because I wasn't sure that, you know, with the acceleration that it just wouldn't pull out. It didn't in the end. But the fact that I mean, all of that worked, you know, getting off the ground, and it was just a standard sort of. So electronics wise, what did you use? I'd started using early in the days a little bit of G-Wiz, but I moved away from that very quickly to the Ravens. And I had been using Ravens ever since. That and the 70mm Beeline GPS. They, you know, that was just a go-to, and I had actually used that right up to the, you know, the really high altitude flights. Combination of 2 Ravens and 2 GPS trackers, and the GPS trackers were timed that
they would not transmit at the same time. They would transmit offset 5 seconds.
Yep, okay, wow.
That's kind of important, but if you only have the one GPS, then you don't really have true redundancy. And each of the Ravens would fire, so you have a primary event. The primary event would have a backup, which 2 or 3 seconds later would fire irrespective. And each of those charges, the primary and the backup charge, and I'm not talking about main deployment, just apogee, had the 2 charges, but each of those had 2 electronic matches in it, both one being fired by Raven 1 and one being fired by Raven 2. So each charge had redundancy, and then there was a second charge that was a redundant charge. So the chances of there actually going something wrong was not going to be because of electronic failure or the charge not working. And the kicker charge, the backup charge, was always a little bit larger. So if something did go wrong and it did not actually get the nose cone off, then that second one would for sure get it off.
So I know we're veering off a little bit, which is fine. What allowances did you make for black powder charges at high altitude? How did you manage that? Did you even use black powder charges?
No, I did. Okay. I did, absolutely. And because it's easy, and especially if you're going overseas, that's the stuff that you would get. Look, there had been. You're obviously talking about the phenomenon where at high altitude the black powder would disperse and you wouldn't get full burn.
Yes.
There were lots of people saying lots of things about that as to how you deal with it. I tried 1 or 2 of them, but I never believed that they would actually work. I ended up going with what I ended up calling the cannon method, which is a little aluminium tube. The way that most of my later rockets worked anyway was a scenario where all of the electronics live inside the nose cone, and it's just the nose cone. Everything is in there. And it had a ARRD, which was that black powder charge release mechanism. So the nose cone would come off with all of the electronics and so on in it. It had a floating piston that was part of that nose cone arrangement, which was held in place by the ARRD. And then at low level deployment for the main deployment, that ARRD would let go and a primary parachute would come out. But the problem with that was that you had to get, for the apogee ejection, you needed to get the explosion that would pull the thing apart. You needed to get it below that primary, that floating piston. So that's where the cannon methodology came through. It was actually a fairly long aluminium tube that originated inside the nose cone, but sort of snuck past that floating piston and was in the primary shockboard bay below the nose cone, below that floating piston. So you would ignite it at the top of the tube, and it would literally fire like a little cannon down into the shockboard bay, and that would pull the thing apart. It did 2 things. It got the explosion to happen in the right location, down below, as far down, basically just above the motor. That would get the nose cone kicked out, but it also meant that the black powder couldn't disperse anywhere, and that worked up to that method was used even on the 64,000 foot flight, and it was flawless.
Wow. Okay. I think I've seen some photos, but I didn't know what I was looking at.
We can have a look later on. I probably have the CAD files for it, because all of that was laser cut and I modeled everything up. So
we'll definitely be talking more about Mad Max 2.
All right.
We'll definitely be talking more about that. So let's jump back a little bit in time then. Can you talk to me about the process of your L3 and the rocket that you use?
Yeah. Okay, so
and why that design?
Well, look, the Sledgehammer, mate. You gotta love that Sledgehammer. It's not a particularly efficient thing, but it looks cool, right?
Yeah.
So I wanted to upscale it. I had, for my level 2, of course, built a sort of mini version of it. But the level 3 was a true and genuine build from scratch. I'd laid my hands on a 10-inch diameter PVC pipe, which I used as a mandrel.
Okay.
And I used the same standard methodology that basically all of us, and I think it was George that taught me the basics of that.
I hate to interrupt, but if I don't now, I'll forget. So when I spoke with George and Len, your name came up, and George said, I was always amazed. You'd just say something to Nick, and he would just absorb it. He would take it away, and he'd come back, and he's like a master at it. It was just like the light bulb went on, and it was incredible.
I was certainly not ever a master in anything, if you ask me, but nonetheless, I do credit George for showing me the basics of composite design there right in the get-go, and I appreciate the effort that he put into showing me. So, anyways, that was a 10-inch PVC pipe mandrel, and the PVC pipes are not perfect in terms of roundness, so it was a bit of a pain to work with it. But what I found tends to work well is cutting plywood discs that you would push into, and that would just sort of force it a little bit more round. Okay. You have to be careful that they don't fit too tight, because then it bulges, and But it helped to keep the thing round, and then just wax paper spiraled around, and then just did lay up, probably 3 millimeters if I remember correctly, and just fiberglass and the araldite epoxy.
And 3 millimeters was your standard thickness for
No, I changed that quite heavily on job by job. Depends on if it's a smaller airframe, you don't need as much, and if it's a bigger airframe, you probably need to go to composites, which sandwich construction, which I had done on things like the Maverick missile, the AGM-65. That was a foam core sort of thing, and the big 10-inch Talon was cork cord.
Yes. I remember seeing inside that. It was cork. You had fiberglass, cork fiberglass. Is that right? Yeah.
That's it. The cork has its advantages, but it tends to be heavier than the core cell. Core cell is that yellow sort of foam stuff. The core cell is very stiff, so it's a giant pain in the behind to get it wrapped around a piece of fiberglass, especially while the fiberglass, while everything is still uncured, it's still wet.
So what's the thinking behind using the cork or anything?
Easier to manipulate.
Okay.
Keeps it fairly light, but because of the porousness, you tend to use more epoxy with no real gain. It's just weight that gets added.
But you still had 2 fiberglass layers.
Absolutely.
So let's say you took the cork out and just had those fiberglass layers, wouldn't it have been that similar strength?
It's not, because sectional modulus is where, how, let's talk in terms of construction. If you drive under a bridge, like a steel bridge there in the city, there near Milton.
Yep.
If you look up the train line that goes over, you've got I-beams. They're literally in an I shape.
Yep.
If you were to take that same I shape and just box it up into a solid piece of steel, it would be just about the same strength, but it would weigh a whole lot more. Yep. If you take that same I-beam and you rotate it through 90 degrees, then the total structural depth has reduced. Instead of that being the structural depth, you turn it like that, then this becomes the structural depth because of gravity working in that direction. Yep. The structural depth of your total sandwich construction is the critical element. The key being that the top and bottom chords, like the I-beam has a top and bottom chord, they need to be structurally connected. The cork did allow that because you had bridging that happens. There was glue attaching the outer skin with the inner skin so that they would, in terms of construction, they would work together. Yep. Okay. It's similar to core flute. If you think about it, if you cut one skin of core flute, the thing is useless, it's floppy. Yep. But if both skins of core flute are are, in fact, I have a piece of coal flute right here. Use that as a prop. Here's a piece of coal flute. Now, I mean, you all know the coal flute. It's got an inner skin and an outer skin and a bunch of bridges. These are essentially little I-beams that are interconnected with each other, and it's because of that that you get that great stiffness out of it like that. However, in the other direction, the stiffness only lasts as long as it sort of bends, and if you cut any of the skins, then it becomes completely floppy. Same principle. What these guys are doing is they're using an inferior structural material, but by way of the shape, they're increasing the stiffness. Okay. And that's exactly why the cork did what it did. I've got an inner skin of fiberglass, an outer skin of fiberglass, and the bridges in between. Yep. And you need a void former of some description. Bigger is better. You know, the bigger the void former, the stronger the total would be because of the structural depth. So
what did the Sledgehammer use?
The Sledgehammer was not a composite thing. I say composite. It was not a sandwich construction. Okay. It was just fiberglass, relatively thick. But you could take the tube and you could squeeze it like that, and it deformed. Yeah. Wow. Okay. It was not a particularly strong thing. That was the body tube.
So maybe talk to me about the nose cone then.
The nose cone, not the biggest of nose cones that I had made, but it was up there with the bigger ones. But the nose cone was same methodology which you might remember from the forum in the olden days, where I would draw up and laser cut from 6mm MDF. You would cut what I called a profile box, which was essentially two sides with a curve that's carefully designed, a curve in it, two of them in parallel, and then two end pieces with a hole through it, which you could then, what you literally do, take a piece of polystyrene, punch a rod through it, and then put the rod inside of that, into those two holes, so that you have this blob of polystyrene that's hanging there. Yep. And then I would use a hot wire, which again you can't buy these things, so what you can lay your hands on is some nichrome wire, J-Car or the likes of those, they sell it. And I made just a little timber frame with a spring-loaded arrangement to pull the wire straight, and a power supply, just a variable voltage power supply, also a J-Car item, and you would just tune it, get the voltage up and down until the wire is just there, and you would need something, a cutting length of about like that, and you would literally just put it on top of the profile box, cut a piece, rotate, cut a piece, rotate, and just keep on, and eventually you would have a pretty accurate profile of a nose cone. The nose cone that I most favored, especially for the higher performance flights that have speed profiles of between Mach 1.5 up to maybe about Mach 4. Yep. Those ones, the von Karman shape, 7.5 to 1 von Karman, was by far the best that I found. Looking at actual rocket designs, once you're above Mach 4, ogive again becomes the more preferred.
Okay. Styrofoam nose cone in a von Karman shape. Yeah.
You would need to give it a little bit of a light sand to just smooth out the ridges and so on. And then nose cones I tended to not do out of carbon fiber. The reason being the carbon fiber is a good conductor of electricity, and accordingly this whole thing ends up being a bit of a Faraday cage, which means basically that pretty much every nose cone that I've ever made was a fiberglass thing.
Okay. Did you do any fiberglass airframes?
Sometimes,
Okay.
depends on what you're doing.
Yeah.
Most of my airframes for the high performance stuff was actually carbon, just
Okay.
because of weight and strength.
Yeah, yeah.
And the carbon is a lot stronger,
Okay.
like double. So,
Yeah.
but it also costs double. So,
What's money?
yeah. Anyway, so I cut these sort of triangles of fiberglass, fiberglass gauze, and then you would just layer that on in a sequential thing around the nose cone. And I also had a roll of fiberglass tow, basically just an infinitely long string of fiberglass,
Yeah.
which every time I completed a roll of gauze, then I would just spin onto it some fiberglass. It gives it strength in a radial sense, but it also just kept the fiberglass in place so it doesn't fall off.
Yeah, yeah.
So, and you would do that every second round or so, run that on there, and it kept it nice close. And then your usual, the thin film that goes on top of that, which you would then later pull off.
Yeah.
So,
That's cool. Yeah.
and that was the method, really.
And tip, were you using aluminium tips?
Yeah, in the early days, I was using aluminium. I would use the spreadsheet that I used to calculate the XY coordinates of the Von Karman shape. I would just zoom in on the tip part, and I would generate a group of points, which on the CNC lathe, then I cut that so that it actually is the correct shape. In later times, it became apparent to me, and I'd mess around with a couple of ideas surrounding that, but the smartest thing was, under the Tripoli rules, the tip needs to be of a ductile metal.
Okay.
It does not have to be aluminium necessarily.
Yeah.
It just needs to be a ductile metal. It cannot be steel, can't be stainless steel, that sort of thing, which is not considered ductile.
Yeah.
But things like copper and brass and that sort of stuff work. So I ended up making these things out of copper rather than aluminium.
Okay.
And the primary reason for that was, you need a certain amount of weight in the nose cone anyway at the tip, as far forward as possible. And you don't really know exactly how much you need until you finish building the whole thing. And then you start messing around with balance and what have you. But you went a long way already by making that tip that you need anyway from as heavy a material as you can. I mean, you could cast it from lead if you wanted to, and that would be even better. The only problem is lead might melt. So copper does not, brass does not.
Wow. Okay.
That worked quite well. I'd contemplated doing things like aero spikes and so on, where you, instead of just the completion of the Von Karman shape, you would actually have an aero spike in front of it that's made of tungsten, something really heavy, but that becomes a bunker buster, right? You wouldn't want to mess with that.
Okay, so now maybe, and the reason I bring some of these things up is because the old forum's gone, so people don't know about these builds. Maybe talk to me about the fins and the fin construction.
Okay, so fins are a difficult thing. Because there's a fair amount of guesswork in it, but I think the key elements here was you need to, depending on what you're doing, what sort of flight this thing is going to do, Mach number is super important. On things like the Mad Max things, you know that you were going to sit with 800 degrees of aerodynamic heating on the fin edges.
For the Sledgehammer?
For the Sledgehammer, it was just sweat. No problem there. The Sledgehammer fins were a 10mm core cell, which is that yellow foam, closed cell structure, and then laminated with fiberglass. And I just had a strip of carbon. Sorry, they were carbon. Yeah.
So, if you want to keep talking about that, otherwise, why don't you talk to us about Mad Max, what the purpose was and what the specs were?
Okay, so there were two Mad Maxes, 1 and 2. Mad Max 1 was, when was that? It's probably about 2014 or so, somewhere there. It was, I flew it at Black Rock Desert in Nevada under the Balls event that Triple E holds there every year. I believe.
Just finished in the last week.
Oh yeah, there you go. Anyways, so I flew it over there. I had wanted to do an N5800 flight, a CTI N5800, and the things have gotten refined later on, but Mad Max 1 was a relatively straightforward thing. It was a fiberglass airframe with carbon fiber fins and a fiberglass nose cone, a Von Karman nose cone, and survival was the only purpose there. So it boiled down to being a successful flight. It went to I think 53,000 feet. The video I still have. I think I gave that to you guys.
Yes.
It is also still as a private video. It's still on YouTube. So that's something that I'm happy to share. For people interested, happy to have a look. It had a GoPro on board, which worked for most of the flight, except not all the way down to the ground. The GoPros were quite finicky.
So why don't you? I remember some quotes. One was something like, "Cracking Mach 3.5 was more difficult than I expected." Something like that.
Well, that may have been Mad Max 2 because Mad Max 2 went to Mach 3.64.
Okay.
And
what did Mad Max 1 go to?
not that fast.
Okay.
Maybe Mach 3, maybe just touching Mach 3.
Okay.
So Mad Max 2 was flown here in Queensland out at Westmar still.
I was there for that flight. That's great. Yeah.
And the videos of that is also still available. It was probably at the pinnacle of me understanding how stuff tends to work in reality. I mean, there's some things that we can talk, but the launch angle is critical.
Yeah.
And I've gone up through trial and error to come up with methodologies where you can maximize your altitude by just pointing the thing correctly relative to the wind.
Yes.
So you don't just aim it straight up. You consider where you're aiming. So there was that, and of course we sat with a handicap here because Westmar is at 400 meters above sea level. It's nothing, as opposed to Black Rock, which is at I think 10,000 feet, 8,000 feet.
Okay. Yeah.
So that handicap of altitude, starting altitude, is brutal. Because you've got lots of dense atmosphere to get through, and of course with an N5800 you're burning all your fuel real quick.
So sorry, Mad Max 2 was a N58.
No, that was an 03400, and that's the only reason why I believe it survived. The 03400 and the N5800 there's only 2% difference between the two, but it pushes it over into the O class. But it's got a much longer burn. I think it's like almost 4 seconds.
Okay.
Same amount of impulse, burnt over double the time, which means that you get through the denser part of the atmosphere before you actually reach maximum speed.
Yeah. Now, so on Mad Max 1, I remember one of the things that you were talking about was the paint scheme.
Yeah.
And how the paint scheme can impact on the performance
It does.
or the outcome. So,
The outcome, yeah, because remember I switched to automotive paint that I bake at temperature in the same oven that I use to post cure my epoxies. It being automotive paint, and it's actually quite resistant. It's quite hard. I mean, it's like a car paint, right? What ended up happening there was on those really fast, high-speed sort of flights, you tended to have the paint almost acted like an ablative layer because the paint job would be wrecked after the flight, but the airframe survived.
Yeah.
And I'd rather have the paint job wrecked than the airframe wrecked. And I still am convinced that that's one of the important things. Unless you're really using materials that can take this sort of temperatures, it's best to just live with the fact that the paint job's going to be wrecked and let the paint burn.
So was that the same type of paint that you used for earlier rockets?
Yeah.
Okay.
Funny enough, yes.
Okay.
The stuff that I bought there in Tingalpa from a paint shop.
Yeah. Okay.
So it's a 2-pack paint. Unicolor is the brand. And the only trick there with that was you needed to learn how to apply it. So very low spray paint. You need a proper spray paint with nozzle adjustment and pressure adjustment and airflows and so on. Top fed, gravity fed. Don't suck it from underneath. But low pressure, low amount of paint flow, and just spray it on.
How many coats?
One.
Okay.
I would use a 2-pack primer. That I would then sand, and I wouldn't actually sand it very smooth either. I mean, literally like 100 grit, like that. Nothing more. Just get rid of little bumps and imperfections in the shape and so on, and then you would spray on the top coat, and that's it. And you let it dry overnight, let it just set, and then in the oven, and you post cure it, and it comes out rock hard.
Wow. Okay.
And yeah.
So what other techniques did you use to ensure that flight was successful? So I know you talked a little bit about the fins. Do you want to talk a little bit more about those?
Okay, so let's
not the number, but what you the construction of the fins.
Okay, so for Mad Max 2, that was probably one of the more complex.
I'm talking Mad Max 1.
Okay, Mad Max 1.
Yeah.
Okay, so
we'll definitely be talking about Mad Max 2 more, don't worry.
Okay, so Mad Max 1 was, it's in the early days where I was just sort of feeling myself through the dark here, trying to, feeling my way through the dark. And so the fins there, at the time I believe that an aluminium core with carbon cladding, shall we say, was the answer, and then the idea had been to try and somehow protect that leading edge. But delamination was always the risk, because the epoxies that we're using, if you've got a single fin that's been laminated up with carbon fiber, this way it's strong. But as soon as the heat gets into the edge, then it starts delaminating, and once it does that, it's game over. So a protective cover. And at the time with Mad Max 1, I thought, okay, well, look, let's how about that leading edge be aluminium? So to get the shock wave away from it. It's before I realized that the Mach number and the angle are linked. We'll get to that in a sec. But the I didn't quite believe that was going to work, so I ended up putting a bit of a stainless steel cap over it, which in the long run became my go-to. You cannot protect you can't make the fin heat resistant enough for that delamination to not be an issue. So I cap it with stainless steel, thin stainless steel.
So how did you attach that to the fin?
You bend it and you press fit it over and you glue it on with high strength, high temperature, and the piece that the stainless steel piece, you would tuck it into the tube itself, so that it's mechanically held in place. It's otherwise it's gonna blow away.
Wow. Okay. So why had you seen other rockets fail as a result of the fins delaminating?
Look, it's a known thing. If you look up on all of the early days high speed flights, fin failure had always been the primary thing. And that's why there are the Americans, they love their aluminium fins, which fair enough. You can use that, but it's it's heavy, and it's right at the very end, at the bottom end of the rocket. So you end up, your whole performance is degraded, because whatever you put at the back, you need to balance with weight in the front, and then the total weight just goes up. So the lighter the fin can, the better. So, but it needs to be strong. So that brings us to the on Mad Max 1. it had an aluminium core that was somehow screw fixed through the inside of the tube. It was the tube itself was just fiberglass, and it was a full body tube, fixed from the inside, and then with quite thick beads, of epoxy, and then layered on with this and that and the next bloody thing. It was a bit of a concoction, but it survived. The airframe was wrecked after the flight. I mean,
really? Okay.
It wasn't broken or anything. It completed the flight, but the paint was wrecked and the fins were showing signs of stress damage. I don't think I would have flown that again.
Okay. I'd seen pictures of the scoured airframe, but I didn't realise there was any sort of physical damage there. I think other than
nothing structural at the point where this thing is broken, but it wouldn't fly again.
Put another one in.
I don't think it would have survived that.
Now, talk to me about the Mad Max 2 fin can.
Okay, so the Mad Max 2 fin can.
And am I right? This was secretive at the time, because I was asking questions. I can't talk about that.
Look, I personally didn't try to keep it secret. I mean, it was on the forum, but more the end product was sort of on the forum. Look, got to talk about the total rocket design, I suppose, a little bit before we get to the fin can, because that's what we refer to as a sub-minimum diameter. So
was that a term, or had there been rockets, sub-minimum diameter rockets, prior to you doing that?
I don't believe so.
Yeah.
I don't know of any.
So did you come up with that term?
Well, it's a minimum diameter, and this thing was smaller, so...
Because I don't remember seeing anything like that before then.
I don't, look, at the time, myself and Mike Passaretti were messing around with things quite a lot together, and it may have been him, actually, coining the term. He'd be a good guy to interview as well, by the way.
Yeah, he was on my list.
Yeah. So, in any case, the sub-minimum diameter, what that basically means is you need to create a custom nose cone that the overall diameter is the same diameter as the case diameter. So that means, by definition, it's a custom nose cone, because nobody makes stuff like that. Yeah. Now, easy enough, because you make every nose cone anyway.
Yeah.
And what I ended up doing was, in the same foam course, the foam core, and then you laminate it up, and then you collapse the foam with acetone and pull the gunk out, and that's your nose cone. Same methodology, 7.55 von Karman, but the OD was 98 millimeters. And then made a composite, a carbon fiber structure that actually bolted on top of the motor itself. That formed the less than 98 millimeter cone that you would slide the nose cone over.
Yes.
And then inside the nose cone, it had an extended base, so it was probably about that long, was straight tube, and then it converged into the von Karman shape. No way to do that other than a custom nose cone, right? So, and that contained the shock cords and that floating piston gizmo and the two cannons and all of the electronics and so on, all tipped with a brass nose tip that was quite long because of the von Karman shape. It was about yay long, but only about that wide.
Why brass for that one?
Weight. Remember the whole discussion around aluminium.
I thought you were using copper.
Copper, brass, whatever you want to use it. Copper and brass weigh just about the same. Brass is copper mixed with tin. So, and you could use bronze. Bronze tend to be more, it's copper and zinc. It tends to be harder to machine, and it's a little bit, it's too hard to machine. So bronze I wouldn't use, but and laying your hands on it was sort of difficult too. But whereas copper and brass, easy. Anyway, it had that fairly long thin skin, the fairly long tip on it that you maximize. If you have to have weight, that's the best place to have it. And have as much as you can right there and reduce the weight. Anyway, we were talking about the.
Mad Max 2.
Well, the nose cone. So if if you have to have weight to get some weight in the tip, and there is no better way than in the tip itself. So instead of just going in with an aluminium thing and then adding lead behind it, it's better to just go with a heavy thing at the front. So, okay, so that was the front end of Mad Max 2, and then the fin can, which is where we were aiming. The fin can was carbon fiber. It was all just carbon fiber, and then with some metal-y parts to it. But it was basically a fairly thick tube that nicely fit over the motor itself. The retention ring at the bottom for the of the motor itself kept the nose cone in place, and I just used some stainless steel shims to just tighten it in place.
So that was one piece?
It was.
The fin can was one piece.
It just slides over, not bolted or anything. It just physically slid over. What I did use there as well was the leading edge of that tube, which was quite, the tube itself, the wall thickness was, I don't know, probably 4 or 5 millimeters. It was quite a heavy tube. But that leaves, everything is the diameter of the motor, including the nose cone, and then suddenly you've got this tube here at the back that's 5 millimeter thicker. Now, what do you do with that? Well, Mach angle and a custom-made aluminium ring that was. So what I did was, we should talk about the Mach angle, we'll get there in a minute, but I took a piece of aluminium flat bar, milled it so that in section it made a sharp tip, and then rolled it into the shape that perfectly fit over the motor itself. And the rear face of it was 5 millimeters thick, and the front face of it was 0 millimeters thick. So it made basically a circular sharp edge, and that was laminated, glued on in some description, and I had welded the joint and
so glued onto the motor mount, the motor case.
Glued onto the fin can tube. There was no need for that to be stronger really than just gluing on, because once it's in place, the motor itself is the thing that holds it together. So it would never, there's nothing that can happen to it. That protected that thick 5 millimeter wall, because that would be a perfect place for delamination to occur, because it's right in the breeze. Okay, and then the fins themselves weren't hollow core or anything. It was just a solid core, quite thick carbon. And I'd done the fillets with epiglue, and the whole lot was then again laminated with vacuum pumped lamination of carbon fiber. From fin face all the way over the tube into the next fin face. And then the stainless steel caps again over the leading edges. So this whole thing about Mach angle, why is it important? It is critical because you will break stuff if you don't follow the rules that it basically provides. Now, I don't know if you remember seeing a diagram that I had drawn and put up on the forum many moons ago, but it essentially, we know what the speed of sound is. It's 342 meters per second, if I remember correctly, 770 miles per hour. So if you have a rocket moving at, say, Mach 3, you take 3 consecutive seconds at Mach 3, and the distance that it would travel in 1 second, you can actually measure out. Now, let's call those 3 points, point 1, 2, and 3. At the first point, the sound starts moving out from that point at 342 meters per second. By the time that the rocket gets to point number 2, the sound originates there, but the sound from point 1 keeps on expanding. And then point 2 sound also starts expanding. A second later, you're at point number 3, and the sound originates. But the sound is expanded 3 seconds already. So if you gauge that up, and it's a graphic thing, you draw it out, and the line that is tangent to the three circles that are formed.
Yep.
There's a tangent line that connects all of them. That is the Mach angle.
Yep.
You would find that on Mach 1 flights, it's fairly steep. It's like 45 degrees or something like that. And the faster the rocket goes, that Mach angle drops lower. That's why the fastest of aeroplanes in the 1950s and 60s, they were very pointy, right? So,
yeah.
And that's because of Mach angle.
Yep.
Now, of course, the Mach angle for things like aeroplanes, there were other considerations because this thing needed to take off and so on. But for our rocketry stuff, Mach angle is only important for one reason, that's survival. Because at max Q, you're going the fastest you can, and it's low in the atmosphere. The atmosphere is densest, so you're really generating heat. And what from a NACA, you remember NACA, NACA, they're the precursor of NASA.
Yep.
There was a white paper that I had read that was basically discussing shock wave forming and how the shock waves collapse back on wings that generates that heat.
Yep.
If the leading edge is at the Mach angle, then the collapse doesn't really occur just at the edge. It occurs over the whole fin or the whole wing.
Yeah.
So that's why Mach angle is important. If you get that right, the fins don't work as hard. You don't have to make them as big or as strong. And that I think was the moment that
Okay.
that made all the difference. You get the Mach angle right, you design your fin correctly.
Yep.
It doesn't suffer from the shockwave collapse that generates the heat that eventually delaminates the thing and burns it. And then all you need to do, the trailing edge, flutter control, you need to just be careful of flutter because the trailing edge of your fin you'd like to have as long as possible, but there is something as too long.
Yeah.
So fin sim is what I use there. So the Mach angle was the starting point, fin sim was the second one that you would, for the speed in question and the material that you were using, you could calculate that's the bridge that you should not cross. The trailing edge should not be longer than this.
And how are you calculating Mach angle?
I just drew it.
Okay.
Literally, I mean, obviously I do a little. I don't know if you wanna have a look at it.
I don't know. I don't want to be on camera, but I can.
Well, look, you can have it on camera if you want. I'll just go here. So, let's just see. We want to do a drafting view. One in, say, 1 in 100. So now 342. Let's say we're dealing with a Mach 3 flight. So what's that? 1142, something like that. So let's say it's 1142 kilometers per hour. Now you would literally draw out how far would the rocket travel in 1 second. So that's divided by 3600. It gets you to seconds. So it's 317 meters.
Yep.
That it would travel in 1 second. So let's just do that. So 317,000 millimeters. So that's how far it would travel in 1 second. Now you draw a circle. Now at second 1, it would start originating, and we've got 317 meters per second. So that's the same. 317 like that, and so if you've got second number 2, this one would be double that. And just times 2. So you've seen this diagram before. You've seen this diagram before. And then we would go there. There's your 3 seconds. That's second number 2. It's there. Like that. And now we're making this into 3-second circle. And we need to times that by 1.5, so like that. And this one becomes a 2-second circle, like that. And then we just have one more in that location, but it needs to be a 1-second circle, like that.
Yeah.
So there's that, and now you draw the tangent. Literally, the line that is the tangent there. That's your Mach angle for Mach 3.
Yep.
And we want an angle. 150 or something like that. No, let's be bigger. 1N because it's a big number. So there, 30 degrees.
Okay.
That's the Mach angle for Mach 3.
Yep.
And it's as simple as that. Basically, you on a graphical interface, you draw what the basics of that science tells you.
Yeah.
The rocket moves a certain distance in 1 second at Mach 3,
Yeah.
and the sound moves at a certain distance at Mach 1. The sound is going out by Mach 1. So that gives you, you can quite easily then work out in that methodology. If your fin leading edge angle is too tight, too big, then there's shockwave collapse, and you're probably going to break the fin.
Okay.
If it's too flat, then you lose performance out of the fin, because the fin is there to help keep the thing straight.
Yeah.
So going too far in the other direction doesn't help you either. You lose stability. So there's a sweet spot, but for that you need to know approximately how fast the thing's going to go, and that's where open rocket came in. So you simulate, and you keep on simulating, and you keep on tweaking. The fins are almost the last thing that I ended up building, the fin can.
Yeah. Okay.
So you're building the airframe, and you start with a nose cone, and you do the tip, and you model it in open rocket, and you override what open rocket guesses the actual center of gravity of this thing is, etc. You weigh it for each component. You physically weigh it on a scale, and you balance it on a thing, so you can know where the actual center of gravity of that component is, and you feed that back, and you override those elements.
Wow. So, and you did that for Mad Max too?
Absolutely, absolutely. Well, I've been doing that for pretty much all the rockets for a while, because open rocket makes an assumption about what the composites that you're using is weighing and so on, but it doesn't know. You can override all of those, and the best thing to do is right at the very end, once you've completely built the whole thing, you load the motor, which you're not supposed to do.
Yes.
You load the motor, assemble the whole thing complete, weigh it, and test the center of gravity. And from the shape, you know where the center of pressure is. And the difference for these high performance must not be just one, because of the move of the center of pressure. You need to know what the center of pressure is at max Q. And that needs to be 1 or 1.1. So you would find that many of Mad Max 2, for instance, I seem to remember it had a stability margin of 2.5 on the pad. And it was necessary, because by the time you get to Mach 3.6, that stability margin, even though you're burning fuel, the speed is so extreme that that center of pressure moves forward, and if it moves further forward than the center of gravity, the thing spins, and that's it. So measuring what you would always find that the stability margin is ludicrously high on the pad. But it's necessary for the flight.
Because it's a ludicrous flight.
For the lower performance flights, the stability margin of 1 is fine. If you're not even going supersonic, it doesn't matter.
And now, one of the other things I remember from that flight that you had to calculate was the high altitude winds.
So I just used a thing called Null School, Earth.nullschool. It's a website which it's mostly based on true measurements, but it's also mathematically calculated. And you can pinpoint where on Earth you are. Wind speeds at surface is one important part, but the wind speeds further up. The higher you go, of course, the speeds tend to go up, but the pressure is down. So the wind might be going at 100 k's an hour at 20,000 feet, but it has no teeth because the pressure is way down. And at 50,000 feet or 60 or 70,000 feet, the wind speeds would be insane. But it's just mere molecules. It's it's not an actual wind anymore.
Yeah. Okay.
So that was important.
So how did you make that calculation then? So you can say, oh, the wind speed's 100 kilometers an hour, but I know that's not going to shift the rocket more than 100 meters.
But because you'd be, I mean, that's a simple calculation from air pressure. So anything that has mass and has movement has momentum, and the momentum is easy to calculate. So, and you've got a certain size of sectional area of your rocket, and at 18,000 feet, 50% of the atmosphere's weight is already below you, and the other 500 kilometers up, that's where the other 50% is. So it doesn't really matter much after, say, 20 or 25,000 feet. It doesn't really matter anymore because it becomes inconsequential what the wind is doing. But to get there, you need to just be aware of two things. The launch at ground level, there's a kick. The moment it leaves the rail, there's whatever the wind, the side wind is, tends to kick it. It weathercocks a little bit.
Yes.
Just a little bit until it picks up enough speed where the relative force of the wind on the fins becomes a percentage so low because it's going so fast that the wind has no effect anymore. But that first 20 or 30 meters is critical, and through trial and error, we found that with the likes of Mad Max 2, where it's a relatively, it's not a particularly tall rocket, as tall as I am, and the fins are about yay size. We found that for every 7 meters per second of wind, you need to adjust your tower 1 degree. And you adjust it away from the wind, always with the wind. So if the wind comes this way, you lean the angle in the same direction as it is. Because once the rocket leaves the tower, it kicks and it kicks upright. And that works. And it buys you 5,000 feet on your altitude just because the thing is going pretty straight up. So that was an important thing. This 7 meters per second, 1 degree adjustment with the wind. That was important. And then probably the last thing behind the nose, the fin can, was the boat tail, which I've become a big fan of. Boat tails are dangerous because they steal stability like nobody's business. But if you calculate for it, the base drag reduction is significant, and that buys you another 10,000 feet in altitude. So how I done that was just quite a thin skinned carbon fiber tail cone, which you just silicon literally onto the back of the so the actual nose cone of the nozzle of the motor itself is made of graphite or whatever they make it from, phenolic. I think CTI made them from phenolic, and I would literally silicon onto the phenolic, physically glue it on with silicon, regular bathroom silicon. It's the only substance that I found that can suck up the heat and survive there in the flame. Bathroom silicon. Jeez. And you would physically silicon it on. The boat tail, of course, narrows the rear, and you would fill the inside face of the tail cone itself. You would fill with the silicon, but make sure to line it up with the expansion cone of the nozzle itself, meaning
Yeah.
you use a straight edge to scrape it in there.
Yeah.
That works beautifully. So the tail cone after the flight looks a bit raggedy, but it survived and it did its job. And as I said, 10,000 feet, that's what it gains you in terms of just reduction in base drag.
Yeah.
But you have to account for it in the simulations because you need an extra half or a 3/4 of a stability margin, just the fact that it has the tail cone on it.
It's got that extra weight.
And the angle of that also you need to calculate that as well because it's a reverse Mach number. You need to figure.
Yes, okay.
It's the nose cone is made for that, but you do it the other way around. Yeah. So you need to make a judgment call. Where is the base drag reduction most necessary? Well, it's after burnout, from the moment of burnout until it hits maybe 20,000 feet, because after that the air pressure is it's inconsequential. So that's the speed from Mach 3 down to Mach 1 maybe.
Yep.
And that's you design your tail cone to cover that zone of speed.
Wow. Okay. Oh, that's awesome. So, where are Mad Max 1 and Mad Max 2, those rockets? What happened to those?
Mad Max 1, parts of it I think I just gave to one of the Western Australian boys, which was there with me. And Mad Max 2, I wonder what happened to that fin can. I don't even know if I still have it. Doubt it.
Am I right in recollecting as well that you made some more fin cans, like the Mad Max 2 can, and sold them to people in the US, or?
Well, it wasn't sold. I only made one fin can. That was for Neil McGilvray, one of the boys from Rockets magazine.
Yeah.
He asked for a fin can that goes on. It was an 8-inch rocket. That he had everything for except the fin can. So I said, yeah, sure, I'll make it for you. And so I made an 8-inch. I made an 8-inch mandrel that was the right size. That was laser cut from structure, and it was a bit of a pain in the ass. But it wasn't a big. It was only about yay long, right? So, and then laid up carbon on that and. Those fins were 10mm core cell, clad with fiberglass and glass, just to get the thickness up a little bit, and weight wasn't all that important. And I had timber leading edges that was then clad with carbon fiber as well. And the whole lot got big fillets, and the whole lot then went in a big ass vacuum bag. It was that was quite a challenging build just because of the physical size. Because,
I didn't realize.
The thing had like an 800mm fin span or wingspan.
I had no idea it was that big.
And it was like that, about like that, in a custom made bloody hot box that I had to make for it. And
so was that for like a high performance launch, or was it just
no, not a particularly high performance, but it was. Look, the Neil McGilvray and his gang, they make their own motors, as you're aware. So he had this 8-inch P or Q motor. I think it may have been a P11,000, something like that, or a Q15,000, something like that. It was a big motor, make no mistake, and. So the fin can had to be a little bit more robust than just normal. But it wasn't a high performance flight in the sense it probably only did about maybe Mach 1.5, something like that.
Big rocket to go that fast though.
Yeah, it's a big rocket to get that fast, and of course he had a deployment problem at this thing. Dropped the main at 40,000 feet, and he never saw it again. It drifted off into the Badlands, and he never saw it again.
Still out there.
It's still out there. he had some buddies in the US military that was, they were trying to get access to military satellites to scour the area. But they never found it. So that fin can only flew once. It flew perfectly, but
no job's done.
Never saw it again. So.
And you've travelled a bit. We don't have to go into too much detail.
Sure.
I know you travelled a bit. How did you find that experience? Like, I've got a few noted down here, like Perth and Victoria in the US. How did you find the experience of travelling, lugging potentially a pretty large rocket around with you to go to rocket events?
Yeah, so that's always a challenge, especially if you're going to the US. But you fork out the dough. I built a custom box that took all of my gear because you need to take your launch tower and everything. Everything needs to go.
Really? Okay.
Unless you have some buddies that can lend you stuff. But for something like Mad Max 1, which flew out at Black Rock, that was a custom tower because so anyways.
So you shipped the tower as well?
Yeah.
Wow, I didn't realise that. Okay. I saw Mad Max in the crate ready to go. And I think I saw the Sledgehammer in the crate ready to go somewhere. Maybe it was Perth.
That was Perth. Yeah, that was Perth. I think it was the same crate in the end.
Yeah.
So anyway, now you FedEx the thing across to Gerlach. Gerlach is the little town just outside of outside of there, and
so it's not carry on.
No. I have done carry on. I mean, when we were coming back from Black Rock, I wanted to bring my N5800 casing back with me, and because I needed it for something else. I couldn't wait for it to get shipped back in X amount of time, right? So ended up taking that as carry on. It wasn't carry on, it was checked in, bubble wrapped to death and so on, but the thing reeks of black powder and propellant and it had grease all over it, none of which is allowed in the aircraft. And now I tried to check this thing in there because I just jury rigged this bubble wrap thing with a strap that you can carry it, and I tried to check it in, and the Qantas lady there behind the counter asks, "What is that?" And I said, "It's aircraft parts." She said, "Does it have any oils or?" No oils. Yeah, it had all of those. It made it back. It had a couple of bumps and so on, but picked it up here at Brisbane Airport.
At least at the end of the day, that's like inert metal.
Yeah.
Have you ever shipped motors?
No, that'll never happen. Strangely, also over here, electronic matches, e-matches are not an issue. You don't need specific fancy licenses for it over here. But funny enough, in the US, they're controlled. You need fancy licenses for it. Yeah. So they made some other e-match over there that supposedly works the same, but that was just dangerous because it was a little blue one which didn't work all that well. You're basically buggered. You have to use what you can lay your hands on, and you can't ship that with you. So e-matches, black powder, all of that you need to source over there. Yeah. So that was quite painful, but everything else is not an issue. It just cost money to ship it. I mean, it was a couple of $1,000s for that crate to get FedEx to Gerlach.
I'm sure you realise, but there was people loading up their rockets into that crate to get
it's no wonder it was so bloody expensive to ship because it weighed a lot. Anyway, that's it is what it is. As far as the travel itself is concerned, I highly recommend if you're able to go to a balls event. Yeah. You have to be a AAA member, otherwise you don't have insurance. You don't have to go and fly necessarily.
I don't think they'd let you on site if you're not launching a rocket anymore.
Oh, is that so?
Okay. Even if you're a AAA member. Or
yeah. Okay, that's quite possible. I do understand also that the event isn't quite as much fun as it used to be. I don't know. The political scene has changed. I don't mean like government political. It's just BLM, the Bureau of Land Management is making things there. It's a different BLM. The Bureau of Land Management is making things very difficult for the rocket flyers over there, and of course the whole Burning Man thing happening in the same location. They reckon that Gerlach itself, like the place that we always used to stay there was, you just don't get room there anymore. There's always just a bunch of burners in there, and they reckon that the entire town is eventually going to get taken over by the Burning Man people.
Wow, okay.
But they still, from memory, and the last I heard, they still have a good waiver. You know, the instrument there, it's like 300,000 feet. It's good.
Yeah, there was an amateur group recently in New Zealand, I think, that went over 3,000 and had GPS recording,
Right.
so GPS proof.
Yeah.
With a 2-stage launch.
Yeah,
Yeah,
nice,
somewhere
nice. Yeah, so no, I mean, things move on, right? You know, in the early days with apparently the Mad Max 1. I mean, it was technically the Tripoli record, and it doesn't stand anymore, of course, but it was the first of the N motors that went above 50,000 feet.
Okay, yeah.
And then subsequently the Mad Max 2, that was the O record for a while. I don't know if that still stands or not. I wouldn't even know, but certainly the you know, the hardcore boys in the US that have gone 2-stage and sometimes 3-stage.
Yeah.
I mean, they completely caned it. I mean, it's.
I've got a video I get to watch, the 2-stage P motor to O motor.
Yeah.
That would be going high.
Yeah. So I mean, there's a couple of things that I wanted to try, never got around to doing it. Like extreme, unbalanced or disproportionate 2-stage, where you have an O motor staging to a J, something like that. And the idea being, you just need to get through that worst 10 or 20,000 feet, and then when you go, then you don't have to work as hard.
Yes. Okay.
And you just design that sustainer really well with, you know, base drag reduction and what have you, and spin stabilization and what have you, and you could do something really wild.
You could still do it.
Where?
So I'm trying to find a site, I've been trying for the last year, in Queensland.
Yep.
Within, let's say, 8 hours drive, that we could get to, I don't know, 30,000 feet.
Yep.
But I do some part-time work for a company in Sydney called Endeavour Aerospace.
Right.
And they've got a site out in the far western New South Wales, and I know they've had launches out there to 70,000.
Right.
And I think if you said to them, if anyone said to them, well, I want a 100,000 foot ceiling, I think they could make it happen.
Yeah. Yeah, interesting.
It's a long drive from here, but
it is far. But look, you know, when I sort of started moving into other things, didn't really lose interest. I just sort of got sidetracked on other things. I mean, work had been particularly hectic at the time. It's hectic now, but it sounded to me like the governmental appetite for allowing us to do what we're doing had diminished significantly. They gave us, and I remember the 100. I was in that meeting where we were discussing the 120,000 foot waiver that we wanted, and they ended up giving that to us for a while.
Yep.
What freaked them out was they thought, 120,000, yeah, sure.
These clowns
what are they going to do? And then I flew that 64,000 foot flight, and suddenly they sat up and said, "Oh, hang on." You know, then not too long after that, I heard that the 120,000 foot waiver had been reduced down to, I don't know, 18 again, or something like that, and it was just never the same again after that. In fact, I think Thunder 2 only had 24,000.
I don't know.
It was something like that. Yeah, it was way different from that first one, which was quite a significant event. You know.
It is pretty challenging trying to find somewhere that has got open land that isn't owned by 50 different households, that doesn't have power lines, that isn't near a town, so it's away from air paths, air traffic. As I said, I've been for a year.
And the power line thing that you mentioned, that's going to get worse because they're rolling out all of these renewables, the wind turbines and solar farms, and the power line distribution network is quadrupling in the next 10 years. So good land for that is going to get even worse. I don't really know what the answer is.
Well, we could, there's a site near Longreach we could potentially use, but then I think, well, it's like an 18-hour drive to Longreach.
It's very far.
It's an 18-hour drive out to White Cliffs, the Dev Aerospace guys that have set up and invested in. It's pointless. We want somewhere closer that's half the height, quarter the height.
Yeah, and it's a challenging thing. So let me ask you a question. Tell me about QRS, how it works at the moment. What sort of launches do you do? I haven't been to a QRS launch for a while.
It's I feel like it's pretty different to back in the early days. So I joined in around March, April 2011. So back then, like you were there launching Ari, you had Landon and George, all these guys. Blake was around. Not one of those people are there anymore. So we have we probably have 2 level 3s in the club. That'd be myself and a guy called Andrew Surtees, who is exceptionally good. He's very good. But that would be it. Even the warrants and stuff come sometimes turn up and just hang around. We've had a long time where we struggled to get motors. So we're kind of hoping that Black Sky, Blake's company, we're hoping to get their offcuts, the leftover scrapings. That hasn't eventuated for whatever reason. So it's been an extreme drought on the motor front, with very few high power motors floating around. So the guys at Endeavour Aerospace have just stepped in and they're now importing motors. But now we're looking at maybe triple the cost of what they used to be. So an M motor now is about $1,500. So the guys that want to do their L3 have got the skills, just can't afford to buy it. They can't afford to burn $1,500. And up till now we haven't had a site where they can do it, a local site where they can do it.
So QRS itself, it's still out at Cedar Grove?
Still out of Cedar Grove. We still launch out there every month. The number of launches has decreased, and the number of high power launches has decreased. But we've still got a lot of kids coming in, and a lot of families coming in, and we probably, maybe not so much now, but one of the big things that's different since you were launching with this, the unis now have the Australian University Rocketry Challenge. So we regularly have UQ and QT students turning up doing flights and tests and certifications so they can carry the motors. We had a bit of a run-in with Energex as well. Where only one side was going to win that. So we now are not allowed to be under the power lines. So we have to rope that off, and we're like 10 metres or 15 metres, whatever it is, in front of that. And as part of that process, we tried to find another launch site in the area and it just came up empty. No one would come.
I hung a rocket or two over those power lines myself once upon a time.
Well, see, back in the old days, we were a bit smarter in that a rocket would get caught in the power lines, we wouldn't call Energex till the launching was over. This time, some guy got his low power rocket caught in the power lines, called Energex straight away, and then like another 4 came raining down. While Energex was there, that's it. Safety violation. They were threatening to shut us down. For a while there. So.
That's a hard fight to win. It seems to me what QRS really needs is a friendly private landowner that's out in the sticks. But who would that be? That's
as luck would have it, as part of my hunt, I found a farmer who's about 4k down the road from Cedar Grove. I said, can we use launching? He said, do whatever you want. I don't care. It's about a 1 kilometre by 1 kilometre square. A few trees, a few dams, a few cows. But he said, I don't want any cars driving on the property.
Yeah.
So now we've got kids and mums trying to drag gazebos,
that's sort of hard.
uphill, and you know some are going to land in a dam or whatever as well.
Yeah.
So yeah, it's more than just finding a friendly landowner. There's a lot of other things.
Yeah.
A lot of other factors, unfortunately.
And the large sort of sites where, like Westmar, that was an ideal sort of thing, but it's a working farm. And there's the problem that the farm owner is not interested really. He's allowing it until he doesn't allow it anymore.
I think that guy's died.
Yeah.
And I think it's his daughter that's running it now.
Right.
And I've sent him a couple of emails and said,
Yeah.
look, I'm the Rocket Club, things are pretty different now, we just want to come out, blah, blah, blah. No reply.
Yeah. Yeah, that farm is a big farm. It's $100 million a year sort of organisation. They don't care. Yeah, they don't care.
I'm working with Western Downs Regional Council, so I've got a person in there that I'm working with, so it's not solo. But yeah, it's a lot quieter than it used to be. A lot quieter. I haven't launched for a while. I've been sitting on an M motor. That once we get some land to launch from,
we're gonna go for
that'll be it.
Yeah.
That's where I'm gonna burn that.
Things like the motor supply, and of course, at the height of what I was launching, the big ones, paying a lot of money for it, but the dollar exchange rate was a lot better. There was a time that it was at equity, and so I seem to remember that M motors were like $400 or $500.
Yeah, I bought a couple of M motors that I launched back then, and it was under 500 for each of those. Now CTI have been very difficult, I believe, because they don't give a shit about it. So they haven't been coming in, and I think shipping from the US is like the value of the motors is half the cost.
Yeah.
The rest is the shipping, and I think that's been killing the guys. But apparently there's a CTI shipment due later this year, so we'll see what happens.
Yeah. Okay.
Yeah, and they're aerospace guys, like young, but a lot of energy, a lot of enthusiasm. Which is great.
Yeah. Cool.
And all your data is now, I don't know if I sent you a link on it. All your data is now in Mega, all that, the 44 gig.
Okay.
So everyone in the club has been emailed and said, this guy, you don't remember him, but this old codger, he used to launch the occasional rocket. All his data's here, videos, pictures, designs, so that's going to live on.
Yeah, that's cool.
Yeah.
I mean, I just looking at it, I haven't looked at the folder for a while, but
I think I've just stuff there, even that Channel 9, the Channel 9 video. That was, terrible. And that guy, that farmer that they interviewed in that article, there's some land there that would be perfect, that he owns it all.
I remember the old twat.
His name, Truman's the guy down Wood Hill. Yeah, I can't remember his name.
Yeah, this 2015. Okay, so there's a bit of. See, that's Mad Max 2. That file you guys have, by the way.
Wow. Okay, I don't think I've seen that yet because
you need
I don't know
you need the software to open it.
But I think there's a viewer. There's a like Google.
That'll work.
Wow.
So this was all plywood cut. If I just go and hide the nose cone for now, there's the cannons that I was talking about, and the floating piston.
Yeah.
And that's that carbon fiber coupler. And there's the ARRD. Two Ravens, and this had one tractor in it.
Pretty simple, really.
Yeah. It is pretty straightforward. I didn't model the fin can for this one, I don't think. But there's the fin design. don't remember doing that in phenolic in the end, but that was definitely the shape. What was that? Here's the I don't remember what that was for. Oh yeah, no, hang on. This is for the motorbike. This is
okay.
the Yagi antenna.
Yep.
I mounted on the motorbike. This was the mount that
okay.
went on.
Nice.
Coupler jig. That's a jig that I made to make the coupler. There's the the jig there. Here's the Von Karman shape.
Yep.
So
It's all still there.
it's entirely available to you guys. I don't know of how much value it is, but it's there.
There's no one in the club that is even remotely close to being able to do that sort of thing at this point in time. Like the uni students, maybe they're enthusiastic, but they don't have the cash to do it.
Yeah, that's of course the this is that flight at Westmar.
Oh, really? Okay.
Yeah. It's in the Mad Max 2 folder.
Okay. Yeah, I've been spending most of my time in the Sledgehammer.
All right.
10-inch Sledgehammer folder.
So that was that flight.
Wow.
That was a honker of a flight. There's
No onboard video.
no, I didn't put that in on that one, but there is some.
10, 9, 8, 7, 6.
This is I don't know, like 3 kilometers away.
3, 2, 1. There it is.
Yeah.
She held together.
Do you see the kick?
Yeah.
Do you see there? It's a little bit to the right, and
Yeah, that's right. Yeah, I was there for that
But
launch.
now we're getting packets.
This was closer.
Next to, okay. Because you were up quite close, weren't you?
Yeah, we were. Because I had to launch it.
Yeah.
This is a slowed down version of the video. The good old days. This might be the original. Still not perfectly straight up. So there's some of the FinSim outputs. That's also in that folder there. There's the flight, and the GPS track should also be, the KML file should also be in here somewhere. There's the KML file that you can open up. There's the Open Rocket files. It's all there.
Yeah, I've dug around. I spent most of the time in the Sledgehammer, but I've dug around in all of it. Photos and videos and 44 gig of stuff.
Yeah.
We went from, I think, I'd done a lot of my stuff in there and it took out like 10 gig or 12 gig or something. So we just.
So, I don't know what else you've got up your sleeve. You want to.
That's covered most of it. I think we've sucked as much knowledge as we can. Is there anything like closing that you want to say? I guess once in a while you ponder that. Sort of, I appreciate. You did give me some advice when I was air starting some cluster rockets about using solid state relays, and I know you gave a lot of other people the club advice as well. So we appreciate that, and
No, of course. I never considered myself to be in any way, all that fantastic at it. But I'm happy to help whomever, So it's happy days.
Yeah. Well, thank you very much for the time. I really appreciate it. It was great launching rockets with you.
Yeah, no, it's I'm glad to hear that QRS is still around. It's a pity that the motors problem has escalated, and of course the change in economics, the exchange rate and so on, has made it more difficult. But hopefully somewhere in future that will pick up again. It does seem like government has a bit of an appetite for helping things like universities and so on. So I'm hoping that once the idea of rocketry becomes a little bit more mainstream, then you have the likes of CASA that might not be jumping up and down so much about basic things that you want to do. But you know what the story is. You know, the basic, you know, CASA has always reckoned that the skies are not there for the
People to
public.
use.
Yeah, it's there for them to control, and they only want the commercial flights and nothing more in it.
Well, the club now has people working at Black Sky, we've got people working at Rocket Lab, I believe we've had people working at Gilmore.
Yeah,
So they had like the university challenges
yeah.
starting to seed a bit of the industry.
Okay, well, that's good news.
But we're always happy to welcome back previous members into our fold.
All good. Is the QRS website still up?
No, okay. We have a new website. It's queenslandrocketry.com.
Okay.
So yeah, check that out.
Rocketry.com.
That's
I'll
what
check it out.
that's doing.
So your launches are advertised there when
Yes.
your launches are
Yes, our launch dates are on there.
on. Okay.
Yeah.
Because that might be,
And, and how to get there.
yeah, I might remember that. So I might for a Sunday morning. It's still on Sunday mornings. I'm
Yes,
assuming.
correct.
Yeah, well, it'd be a good thing to come out and just come and say hello.
Yeah, of course.
I doubt that there would be many people that I know still. Probably only yourself, really.
Well, do you remember Warren McKay? He sometimes comes out. Len,
Yeah.
remember Len? He
Yeah.
usually comes out. He regularly comes out.
Warren and myself are the only two people that ever burned down the paddock.
Yes, it's quite a reputation. Yeah, geez, because you burnt the one down in Victoria,
Yeah.
wasn't it? And then,
Spectacularly so with a Sparky.
geez.
Man with a pest.
Well, that's when Dave Brennan came out of the woodwork after we burnt the one, after
Right.
Warren burnt the one down. Like that.
Yeah. Yeah, I remember. I was the only good thing there that came out of that was the fact that it was for once not me.
Hooray! Yeah, that's
Yeah.
good. Awesome. Yeah, thank you very much. Any final words? We'd love to have you back. There's always room for one more.
No, appreciate that, and I'll take that seriously under advisement. Even if it's just for coming to say hello. I've basically moved out of rocketry altogether at this point. I have sold all my gear or gotten rid of it in some fashion. There's only little bits and pieces left, but the interest is still there.
Yeah.
So I might just come and say hello the one Sunday morning.
Yeah, that'd be great.
Hope to see some faces that I recognise.
Yeah, good luck. Maybe even like the university groups, the guys trying to push the boundaries a bit. Anyway, we'll talk more about that later.
Yeah.
Thank you very much, Nick. Really appreciate the time.
Thank you.
It's been wonderful. I can't believe it's been like 8 years or something.
It's been a long time. Yeah, I was just looking at some of the dates there. 2015, 2016, and the trail completely goes cold after 2018. So
Yeah.
So it's been a long time. Yeah.
Alrighty.
Cool.
Thank you very much. I really appreciate the time, Nick.
Thanks, mate.
You don't expect to get paid for this, do you?
No.
That's lucky.